In an unprecedented move in October 2023, Vladimir Putin ordered the withdrawal of Russia's Black Sea Fleet from its historic base in Sevastopol. By March 2024, the fleet had endured significant damage, losing one-third of its 80 ships. The catalyst for this shift? Ukraine's sea drones. Conflict often spurs rapid technological advancements, and Ukraine's innovative response has been no exception. Ukrainian engineers and inventors have developed a fleet of advanced sea drones that have effectively neutralized the advantage of a much larger adversary. These drones have not only disrupted Russia's dominance in the Black Sea, but also redefined the standards for modern naval warfare in the 21st century. Today, we'll see how Ukraine's sea drones have transformed the battlefield. Let's first understand what sparked this innovation. The need for sea drones stems from the significant naval power disparity between Russia and Ukraine. Russia's formidable naval force includes an array of destroyers, cruisers, frigates, large landing ships, and nuclear attack submarines. In stark contrast, Ukraine entered the war with a much weaker navy. Its small fleet, consisting mainly of older vessels, was largely ineffective against the superior naval force. Many of the nation's ships were either scuttled, captured, or relocated to avoid destruction. This disparity in naval power placed Ukraine at a severe disadvantage, making it challenging to counter Russian dominance in the Black Sea early in the conflict. The Black Sea is of immense strategic importance. It serves as a crucial maritime gateway, facilitating commercial and energy transit and acting as a vital military theater. Control over this area has historically been a key objective for regional powers, providing access to essential shipping lanes and enabling the projection of naval power. For Russia, maintaining a strong naval presence here is crucial for securing its southern flank and supporting operations in the Middle East and beyond. Sevastopol, the primary base for the Russian fleet in this region, is strategically positioned to exert influence over the entire area. Faced with this imbalance, Ukraine turned to innovative tactics, notably developing and deploying sea drones as part of its asymmetric warfare strategy. These drones began to change the dynamics of naval engagements in the Black Sea. On October 29, 2022, the Russian-occupied port city of Sevastopol witnessed an unprecedented attack. 7 small maritime drones, each about the size of a paddle canoe or kayak, maneuvered through Sevastopol's naval harbor while aerial drones flew overhead. These sea drones operated in coordination, targeting an M-class sweeper vessel and a frigate serving as the flagship of Russia's Black Sea Fleet. Although the immediate impact on the ships was minimal, with neither sustaining significant damage, this attack marked the first time any nation had integrated unmanned naval vessels into a coordinated assault. This innovative use of sea drones demonstrated their potential to disrupt superior naval forces, highlighting a new era in naval warfare where smaller, more agile and cost-effective systems can challenge traditional naval power. Just a quick moment before we unveil the rest. If you're new here, consider subscribing to this channel. Stay up to date and never miss out on the latest insights. The first sea drone deployed during the conflict was the Mykola. This 5.5-meter-long drone can carry 200 kilograms of explosives. Designed for speed, it features a streamlined hull and a motor that allows it to reach up to 43 knots, around 80 kilometers per hour. It has a range of up to 800 kilometers and can operate for 60 hours, streaming live video to its remote operators, providing a crucial first-person perspective. But the Mykola was only the beginning of Ukraine's advancements in sea drone technology. In November 2022, the country introduced the Magura V5, named after a Slavic war goddess. This model prioritizes agility and maneuverability, sacrificing some explosive power for better performance against moving targets. Measuring 5.5 meters in length and 1.5 meters in width, it can travel up to 800 kilometers, carry a payload of 320 kilograms, and reach speeds of 42 knots. It is equipped with an autopilot system, night vision, and an onboard data hub, and costs considerably less than $300,000 per unit. In the summer of 2023, Ukraine unveiled the Sea Baby, a versatile platform capable of mine-laying and striking stationary targets. Despite its unassuming name, the sea drone packs a powerful punch, capable of carrying up to 850 kilograms of explosives and reaching speeds of 90 kilometers per hour. It measures 6 meters in length and can travel up to 1,000 kilometers with additional fuel. Its speed and small size make it a difficult target for enemy defenses, and it features multiple redundant communication systems to ensure reliability even under electronic warfare conditions. By late 2023, the Sea Baby had evolved into a multi-purpose platform, incorporating RP-60 and thermobaric rockets, enhancing its combat capabilities. The latest edition, the Sea Baby 2024, can carry up to 1,000 kilograms of explosives and is priced around $200,000 per unit. The latest addition to Ukraine's sea drone fleet is the Magura, revealed in December 2023. Named after a folk hero, it excels in both speed and technological sophistication. It is the fastest object in the Black Sea, with a top speed of 110 kilometers per hour. Equipped with advanced sensors such as gyroscopes, laser rangefinders, and marine radars, it offers precise navigation and targeting even in challenging conditions. It is designed to reach and detonate upon impact with its targets, making it a formidable weapon against large naval assets. Its construction includes bulletproof materials and a robust satellite communication system, enhancing its durability and control during missions. Technological innovation has been at the heart of Ukraine's development and deployment of sea drones, significantly enhancing their capabilities in the conflict with Russia. These drones combine advanced stealth features, commercially available components, and sophisticated communication systems to create highly effective unmanned surface vessels capable of carrying out complex missions. Their stealth features are key to their effectiveness. Constructed primarily from plastic, these drones are difficult to detect by radar due to their low radar cross-section. Additionally, they have a low heat signature, which enhances their stealth capabilities. This low thermal visibility is largely due to their electric motors, which generate less heat compared to traditional combustion engines. Painted black and sitting low in the water, the drones are even harder to spot, especially at night. This combination of stealth features allows them to approach their targets undetected, increasing the likelihood of successful missions. Another remarkable aspect of Ukraine's sea drone program is the use of commercially available components. This approach not only reduces costs but also accelerates production and deployment. Components from small watercraft, jet skis, off-the-shelf logic boards, antennas, and even virtual reality headsets are used in their construction. This method ensures a steady supply of drones without relying on complex supply chains. Furthermore, many parts can be 3D printed using commercial printers, making it easier for local workshops and individual innovators to contribute to the production process. Additionally, the autonomous capabilities of these sea drones represent a significant leap in modern military technology. Equipped with advanced sensors, including gyroscopes, laser rangefinders, and marine radars, the drones can navigate and operate with high precision. These sensors allow them to maintain stability, orient themselves accurately, and detect and avoid obstacles. The autonomous features enable them to carry out missions with minimal human intervention, enhancing their effectiveness and reducing the risk to operators. Communication technology also plays a vital role in the operational success of Ukraine's sea drones. Starlink, a satellite internet constellation developed by SpaceX, has been instrumental in ensuring reliable communication between the drones and their operators. The use of Starlink provides high-speed, low-latency internet access, allowing real-time control and coordination of drone operations. This capability is especially crucial in environments where traditional communication infrastructure is compromised or unavailable. In addition to Starlink, the drones are equipped with backup communication systems to ensure continuous operation even if the primary link is disrupted. These redundant systems are essential for maintaining control over them in the face of electronic warfare measures employed by Russian forces. The ability to switch between communication channels ensures that the drones can complete their missions despite attempts to jam or interfere with their signals. By now, it should be clear that Ukraine's fleet of sea drones has revolutionized naval warfare, delivering results that are nothing short of extraordinary. Ukraine's use of sea drones has marked several significant military engagements, demonstrating their effectiveness and strategic value. One of the earliest successes, which we have already discussed, was the Sevastopol attack, setting the stage for subsequent operations. Following this, in August 2023, Ukrainian sea drones thought to be Magura models targeted the Russian landing ship Olenogorski Gornyak. This 4,100-ton vessel was attacked while docked near Novorossiysk, far from Ukrainian shores. A drone loaded with 450 kilograms of explosives navigated through defenses and struck the ship. causing severe damage and highlighting the reach and precision of Ukraine's drone capabilities. Another major operation involved repeated attacks on the Kerch Bridge, a critical link between Russia and the Crimean Peninsula. The bridge, symbolizing Russian control over Crimea, has been a top target for Ukraine for both strategic and symbolic reasons. In July 2023, Ukrainian forces used Sea Baby drones to carry out a surprise attack on the bridge. Each drone, carrying nearly 1,700 kilograms of explosives, targeted the bridge's support columns, causing substantial structural damage. Although the bridge did not collapse, the attack significantly disrupted traffic and demonstrated the vulnerability of such critical infrastructure to unmanned systems. Toward the end of 2023, Ukraine conducted a successful attack on Russian landing ships in the Crimean Peninsula. This operation targeted two vessels, a Cerna-class and an Ondatra-class. Footage released by Ukraine showed at least 3 sea drones involved, with 2 impacting their targets. Both vessels were reportedly sunk. In 2024, Ukraine's sea drone operations continued to gain attention. On February 14th, Ukraine successfully targeted the Russian landing ship Cesar Kunikov using Magura V5 drones. This ship, designed to carry 98 crew members and additional military equipment, sustained significant damage from the attack. Following this, in early March, Ukraine targeted the Russian patrol ship Sergei Kotov with the same type of drone. The Sergei Kotov, a modern 1,700-ton vessel equipped with advanced defense systems and commissioned in 2021, was hit multiple times during a coordinated nighttime attack near the Kerch Strait. Ukrainian sources confirmed that the ship sustained severe damage and eventually sank. This loss was particularly significant for Russia, representing a considerable investment in their naval capabilities. The strategic and economic impact of Ukraine's sea drones has profoundly reshaped the dynamics of the conflict with Russia. From a strategic perspective, one of the most significant advantages is their cost-effectiveness. Traditional naval assets, such as ships and submarines, are extremely expensive to build and maintain. In contrast, sea drones can be produced at a fraction of the cost. For instance, a single sea drone might cost between $200,000 to $300,000, whereas a modern warship can cost hundreds of millions of dollars. This cost disparity allows Ukraine to deploy large numbers of drones without straining its budget, enabling it to exert considerable pressure on Russian naval forces. The relatively low cost also permits Ukraine to continually experiment with and refine its drone technology, leading to rapid advancements and increased effectiveness. The ability of these drones to disrupt superior naval forces is another critical advantage. Despite Russia's larger and more technologically advanced navy, Ukraine's sea drones have managed to inflict significant damage on Russian vessels. This disruption is not just physical, but also psychological and strategic. The constant threat of drone attacks forces Russian ships to remain on high alert, potentially reducing their operational efficiency and effectiveness. Furthermore, the need to defend against these attacks requires Russia to allocate resources and manpower that could otherwise be used for offensive operations. This defensive posture limits Russia's ability to project power and control the maritime domain effectively. Economically, the impact of Ukraine's sea drones on Russia has been significant. The destruction and damage inflicted on Russian ships represent substantial financial losses. Replacing or repairing these vessels is costly and time-consuming, putting additional strain on Russia's defense budget. Moreover, the strategic use of sea drones has disrupted the country's supply lines, exacerbating logistical challenges. For instance, the repeated attacks on the Kerch Bridge have not only damaged a vital piece of infrastructure, but also hindered the flow of supplies to Russian forces in Crimea. This disruption increases the cost and complexity of maintaining Russian military operations in the region. The closure of the Dardanelles and Bosporus Straits under the Montreux Convention further compounds these logistical challenges. With these crucial waterways closed to Russian warships, the replenishment of naval assets and the movement of supplies have become significantly more difficult. This bottleneck forces Russian ships to take longer, more circuitous routes, increasing fuel consumption and transit times. The extended supply lines are more vulnerable to interdiction, adding another layer of risk and cost to Russian operations. The international reaction to Ukraine's innovative use of sea drones has been profound, influencing global military strategies and prompting naval powers worldwide to reconsider their own policies and preparations. Countries around the world have taken notice of how Ukraine has effectively used these unmanned maritime systems to disrupt and damage a superior naval force. This success has led to increased interest in developing and integrating similar technologies into their own military arsenals. Nations now recognize that unmanned systems can serve as force multipliers, allowing smaller or less well-funded militaries to challenge larger, more traditional forces effectively. One of the most significant impacts has been the shift in naval policies to emphasize drone warfare. Navies traditionally focused on large manned vessels are now investing in unmanned technologies that can perform a variety of tasks, from reconnaissance and surveillance to direct attacks. This shift is driven by the realization that drones can operate in environments too risky for manned vessels, providing strategic advantages without putting human lives at risk. Additionally, the cost-effectiveness of these systems allows for more extensive deployment without the financial burden associated with traditional naval assets. As nations recognize the strategic benefits of sea drones, they are also taking steps to counter similar threats. Defensive measures are being developed to protect against drone attacks, including advanced radar systems, electronic warfare capabilities, and physical barriers. Countries with significant naval assets such as the United States, China, and the United Kingdom are leading the way in these preparations. They are conducting research and developing technologies to detect, track, and neutralize unmanned vessels before they can reach critical targets. Enhancing radar and sensor systems to detect small, low-profile drones designed to evade traditional detection methods has been a primary focus. These advancements aim to provide early warnings of unmanned threats, allowing for timely defensive actions. Additionally, electronic warfare capabilities are being improved to disrupt the communications and control systems of these vessels. By jamming or hijacking the signals used to operate them, naval forces can prevent them from completing their missions. Ukraine's innovative use of sea drones has dramatically shifted the landscape of naval warfare. Their success has sparked international interest and has led to a global reassessment of the role of unmanned systems in modern military arsenals. Looking ahead, Ukraine's commitment to advancing its sea drone technology promises to keep it at the forefront of naval innovation. Through international collaboration and a focus on training skilled personnel, Ukraine is well positioned to continue shaping the future of naval warfare,